Welcome back, everyone. In this video, I'm going to give you an introduction to object-oriented programming, creating classes. Now here we have our example. Suppose you want to create a program that will allow the user to set the length and width of a rectangle and then be able to calculate and display the perimeter and the area of that rectangle. The perimeter of a rectangle is just the sum of all the sides. The area is obviously length times width. What we're going to do, as you can see that by the code I've created, is we're going to create a class, which is what we've done to this point in Java, but it's going to look very different this time. When we create a class for our rectangle, what it's going to do is it's only going to contain specific variables related to a rectangle and methods to take actions on that rectangle. This is where object-oriented programming becomes different than the programming we've done to this point. If you remember looking at the earlier PowerPoint slides about this iPod example, that's similar to what's going on here. It's basically a way to use abstraction, which means whoever's using our class doesn't need to know how it works. All they care about is it does work. So what we have to do is figure out what variables are involved in a rectangle. Obviously, that's length times width. And then also what methods we can have with a rectangle. Now, you don't have to have absolutely all the methods I'm going to show you, but in general, for object-oriented programming, this is what you will tend to do. You're going to need functions to set values of the variables and to get or retrieve those values of those variables. You could also use methods to do other calculations, like for the perimeter and the area. Variables in a class in Java are referred to as fields. And these fields have a type and a name, just like you would in a regular Java program. Difference is, though, you do not give them initial values. You declare them, but you don't give them initial values. As you can see here in my code, I've created a class named rectangle, and I'm going to give it two fields, one for the length of the rectangle and one for the width. Now then, the way fields are accessed in the way this is defined, you can just, once you create a main program and create objects of this class, here's a way you create objects of a class. This is a class called student. You would just use the name of the class, in this case student, and give it names. Here we have an object named S1 and one named S2. And then you say it equals new, and then name of class with parentheses. This is how you create an object of a class. Similar to how we created a scanner object. Works very much like that. Now here, in these examples, we're just going to use the dot notation to access each variable within the object. Each object you create gets its own copy of each variable and each method. Now, for methods in a class, you still need the word public in front of it. You still must give the method a type. In this case, in this slide, the type is void. You do not use the word static in this case. You're going to leave out the word static, and then you must give the method a name, and you must put parentheses after it. Yes, methods in a class can have parameters. They are not required to. So as you can see here in the code example, I've created several methods. Let me focus on each type of method. Okay. So for example, here we have two types of methods that are categorized as mutators. They change values of class variables. Typically, a mutator method will have the word set in its name. Doesn't have to, but that's a pretty common thing to do. A mutator will often have a void type. It'll have at least one parameter. As you can see, I'm setting the length class variable equal to that parameter. Same thing for set width. Similarly, I also have a couple of methods called accessors. These are get methods. These just return values of class variables. They are often non-void. They often do not have parameters, and they often have the word get in their names because you're getting a value out of this method. Now, it is not absolutely required that you create a set and a get method for each class variable. You can, but you're not absolutely required to do that. Most programmers do, but it's not absolutely required. Furthermore, I have two more methods, which even though they have the word get in their name, don't really qualify as accessors because you're not just returning the value of a variable. Here, I'm calculating and returning the value of the perimeter of the rectangle, 2 times length, 2 times width. And here I am returning the area of the rectangle, length times width. I'll get to my main program in just a second. But one more type of function you need to be aware about, or method, is this one here at the top. It's called a constructor. And it's right here. Now, again, you are not required to have a constructor in a class in Java. If you don't create a constructor, not to panic, Java has a built-in default constructor that you can use. And what it will do is it will allocate the proper amount of memory for an object of the class, and it will also set each class variable equal to its 0 equivalent value. In this case, we have 2 double variables, so each of those would be set to 0.0. However, once you define your own constructor, as I have here, as you can see, the thing in the circle, you are not going to use the default constructor. You're going to use this one, the one you have defined. A constructor has the word public. A constructor does not have a type, not even void. You must name the constructor the name of the class, always. And a constructor is not required to have parameters, but it can. Pardon me. In this case, we have 2 parameters. And in this, I just happen to use the set length and set width methods to give my class variables values. I could have just said length equals len and width equals wid. I didn't have to use the set length methods here, but I just thought it looked cool. You're also allowed to have more than one constructor. You can overload constructors. Okay. So there's an example of a student class with a constructor. Let me show you how main looks. Now, any program that creates objects of a class and then uses it is called a client program. Main would be an example of a client program. And in this case, I have main in its own separate .java file. As you'll see in the next video, however, you can put main in the same file as the class you define. But in this case, I'm doing it separately. So what I have here, these first 2 lines are creating two objects of this rectangle class. I'm calling the first one R1. And since I'm not using the default constructor, I'm using the constructor I created with two parameters. So I must give the length and width values. In this case, the length for R1 is 5.1 and the width is 6.3. I've also created a second object of this class called R2, whose length is 11.5 and whose width is 7.9. Now what I'm doing here is I am going to display the data from each class. For R1, I'm using printf along with my placeholders. I'm rounding the length and width to 1 decimal place. Notice I'm just saying R1.length. I could have called the getLength function and the getWidth function here. I just didn't feel like it, but you can do it. However, on the next line, I'm displaying the perimeter and the area, and those are related to functions. So to get the actual perimeter and the area, I must call the functions that go with those. And I just noticed that if I want to display R2's data, I have to change all my R1s to R2s in this second group of printfs. So pardon me while I do that. There we are. Okay. So let me show you what I get for my output. I'll compile this. Now when I bring up the box, when you have two files, here's what the box looks like. My rectangle file, my rectangle.java contains my rectangle class. And in this case, my Chapter8Lab1 file contains main, the client program. Look what happens in the box. There's the rectangle class. It has its own box, but then Chapter8Lab1 is the class that contains main. And notice this arrow that points from Chapter8Lab1 to rectangle. That arrow indicates that the Chapter8Lab1 file is using data from the rectangle file. Now, of course, Chapter8Lab1 is the file that contains main, so I will right-click on that one and select main to run it. And when I do, here's what I get. There is R1's length, 5.1, its width is 6.3, and there's its perimeter and area. Similarly, for R2, its length is 11.5 and its width is 7.9. And there we have R2's perimeter and R2's area. This is your introduction to object-oriented programming. If you have any questions, please send me an email at kmuldrow@lbcc.edu.